Okay, welcome. Before we get started, I want to mention a couple of things briefly, um, just regarding how to, maybe more tools for studying and approaching this content because there is so much of it. I wanted to remind you, or maybe you're hearing it for the first time, under HESI Prep Tools, there's a link called Padlet Boards. You can open that up, and this is what you're going to see, something that looks like this. These are not required. I think all of you or most of you have probably done something with Padlet. Uh, I know in Gateway to Success we use it. I use it in advanced, so if you require it. So if you take me for advanced, one of your weekly checkoffs is to do a Padlet um, comment. So anyway, these are for general, they're not required. I may implement them at some point and require them, but just show you kind of what they look. Let's go to Skeletal. This week we're going to start in on Skeletal system. But here's what my general A&P Padlet boards look like. So they're going to be a series of basically thumbnails, videos. You can click these and go out into YouTube if you prefer the big screen. But yeah, you can click on any of these, and most of them are relatively short. They run anywhere from 5 minutes up to maybe 10 or 15. But anyway, for the most part, these are some of the checkoffs that the state wants us to do. So anyway, now this one, calcium homeostasis and bone, we get into a little more detail with that in physiology or in advanced, but anyhow, just more tools for you to look at. Like I say, they're definitely not required. All right, so don't forget about those. Let's see, and then we've talked about Quizlet as, of course, an excellent tool to use as you guys are prepping. All right, about half of you. I think nine out of, I think there are 20 of you. Nine of you have submitted the Unit 1 assignment, and which is excellent. That is, you're right where you should be. At this point, the Unit 1 assignment, you should be wrapping that up, or at least, like I say, being uh, done with it, which nine of you are, or close to being done with it. If you're just starting on it, probably want to pick up the pace a little bit. But anyway, that's so in essence, I would say module one, we're going to move on for the most part. There are a few tissue and skin items that I do want to mention this morning, very briefly, because I do want to jump into module two, which is going to be bones and muscles. When it comes to McGraw-Hill, kind of the same deal. You should, I'll go over there now. Probably going to have to log back in, which is fine. There we go. So as far as McGraw-Hill, and again, you kind of want to be doing your unit assignments and your McGraw-Hills concurrently because they're very similar to one another. But also, I want to remind you again that these two e-techs, in addition to OpenStax, of course, you may want to look into the AMP key concepts as well as the practice atlas for AMP. So at this point, like I say, ideally you've completed the Unit 1 slash Module 1 lab assignment, and you've also completed the Unit 1 orientation of the body, as well as cell structures APR and tegumentary APR, and the Module 1 exam. So again, ideally, that's where you should be. I saw that several of you have started working on, some of you have completed the skeletal system APRs. So this is where we are today. Now, unit goes, you could work on this for the next couple weeks. Next week in lab, we are going to focus on our first dissection, though. We are going to do the brain and the eyeball. So I'm not going to do that much in the way of lecturing. So you're going to find your whatever we don't get through today with skull and bones and muscles. You're going to see all of that certainly in the course YouTube channel. I have my lecture videos there as well. So anyway, you want to be working on these as well as, and there's only one for muscle. So basically, you have five of these APRs and then one exam. All right. So ideally, over the next couple of weeks, I'd say this week and next week, you'll work on your Unit 2 packet. So let me go ahead and pull that up. Okay. And again, in my PowerPoint or Google Slides, whatever you want to call it, the presentation, a lot of these are going to be in there. So you'll hear me discuss some of these today. Um, you may not see these in your McGraw-Hill. These are going to be more definitions that are going to be found in my lectures, and certainly you can Google these as well. Uh, Basically, from what I could tell, it looks like there are a few diseases in here, but we'll start talking about muscle cells, kind of bone cells, bone tissue a little bit. And then it looks like there's a little bit on joints in through here. And then we start in on muscles toward the end. It takes us to 98, so under 100, a few, gosh, you had like about 160 or 170, I want to say, with your first one. So quite a bit fewer this time. So that's nice. And again, some of these do have some physiology vibe to them, which is fine. We do go back through muscles and how muscles contract. We really focus a lot on the micro scale of the muscular system next semester. So, don't get too bogged down by these 98 terms, but you should certainly have a decent grasp on them. Oh, speaking of that, I'm in the process of putting together a final exam study guide. So I've got, so what I'll probably do sometime this week, so keep your eyes peeled, make sure you're checking your announcements and emails. I think I'm going to have maybe kind of like a running Google Doc that'll have kind of like sections of key concepts that you're going to want to definitely have a good grasp on for the final. I mean, I know there's so much to there's just so much information. I get it. So I do want to kind of hone it in a little bit and give you kind of a study guide, if you will, for the final exam. So you could kind of be working or kind of looking at that. So like as you've concluded this first module of Intro to the Body, cells, chemistry, cells, tissues, a little bit of skin, I want to pump out a study guide that's going to have some of the key concepts, maybe some sample questions that you might see on the final regarding Unit 1 slash Module 1. And then I'll do the same for module 2, etc. And then at some point, hopefully in the next few weeks, I'll have just the entire body of work. So then you'll have a study guide because it is going to be the final exam is going to be about 95 kind of black and white multiple choice questions. And then you'll have another maybe 50 or so multiple choice questions, but they'll have diagrams, illustrations, images, things like that. Um, so anyhow, just keep that in the forefront of your brains as you get going, as you're moving forward. So anyhow, so the rest of this activity, of course, is going to be um, identification stuff. So, and again, my PowerPoints talk about all of this. This is basically what you're doing in McGraw-Hill for your APRs. So, at this point, when you go over to McGraw-Hill, beep boop boop. So, skull and associated bones. So, if I open that one up, there we go. So when we open this one up, you're going to see some of the skull features, and some of those skull features are going to be aligned with, beep, 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 here we go, some of what you're going to see here. And not just this first one, but, you know, see, as you go through and do the McGraw-Hill uh, APR, you're going to be able to complete the skull identifications. And again, for J through M, I'm looking for the sutures. All right. And then the next stop, it gets into the vertebral column and ribs. So you'll want to take a peek at those. All right, let me go back. Anyhow, so at this point, I think you guys are all very well attuned to McGraw-Hill and your unit assignments. Okay. So anyway, going back, vertebral column. So that's the next batch, and that's what you have here. Okay. And then we get into more appendicular skeleton, pectoral girdle and upper limb, and then pelvic girdle and lower limb. So again, you'll you'll get to understand and vibe with the bones and through the McGraw-Hill as well as through your unit assignments. Now, there's a section here on joints as well. And again, as I think several of you, hopefully all of you, are using the course YouTube channel. I have the keys in there so you can check your work. All right, and then it gets into the muscles and the muscular system. All right, so that is your Unit 2/Module 2 lab assignment. Okie doke. Questions on any of that? Okay. So I've bombarded you with some of the intro basics, some of the chemistry basics, carbs, proteins, fats, vitamins, minerals, water. Uh, got into cells and all of the different cell structures and some of the basic functions of those. And then we started to get into tissues a little bit. So I just want to touch on a few things with tissues. Um, There are four types of tissues. We got into this last week a little bit. So you definitely need to know the four tissue types and a little bit about each one. So again, epithelial, connective, muscular, and nervous. We said epithelium is a covering or a lining. Okay. Generally speaking, it doesn't have a blood supply. It gets fed from deep to it. So the connective tissue is deep to the epithelium, and that's where we're going to find the blood supplies. So blood supply is contained in connective tissue. And again, when we're dropping off or picking up anything regarding chemicals or chemistry, it's going to be capillary networks of the cardiovascular system where that transfer in or transfer out occurs. So, epithelium, lining or covering. Connective tissue is just deep to epithelium, and it's a little more complex, I would say. This is where you're going to again find blood, you're going to find nerve supply. Uh, the definition of connective tissue is cells inside of a matrix. So there's going to be some sort of extracellular or outside of the cell matrix. Oftentimes it's fluid, sometimes it's kind of uh, gelatinous, sometimes it's solid. So you have different, types of media that make up the matrix, the extracellular matrix. Plasma, of course. All right. And then deep to the connective tissue. So we're basically going from superficial to deep. So deep to the connective tissue is going to be muscle tissue. And the muscle tissue, we're going to have three types. Okay, so the three types are smooth, skeletal, and cardiac. So again, we got into that a little bit last week. And then lastly is nervous tissue, which is kind of scattered throughout connective and muscle. It does plug in at the base of epithelial tissue, but again, nervous tissue is pretty ubiquitous. It's kind of all over the place. So we're going to see a couple different types of cells. Next week, in essence, we're going to be starting in on the nervous system when we do our dissections of the brain and eyeball. So next week, I'll talk a little bit more about nervous tissue, and then, of course, in our YouTube lecture videos, as you move forward, you'll be exposed to nervous tissue then. All right, so anyway, extracellular matrix, thinking of that related to connective tissue for sure. All right, so there's that. So outside of the cells, there's a medium that's going to contain all kinds of goodies. So, and again, usually this is going to be composed of a lot of water and then several different proteins and other items in there. You can read that a little bit if you'd like. Epithelium, this is kind of um, there we go. I like visuals. Black and white writing like this doesn't really like that. It's kind of boring and doesn't really do it. It's just a bunch of words. So we go here, we see a more dynamic vibe. So when we think about epithelial tissue being a lining or a covering, the cell structures, its cell types, cell shapes are a little bit different from organ to organ. So some organs have epithelial tissue that's going to be flat cells. Some of the tissues are going to have cube shapes, and some are going to have column shapes. So we're going to have squashed cubes and columns. Those are going to be your options regarding the cell shapes. Now, a lot of tissue is going to have potentially a couple different types. So we see like the epidermis. Kind of at the base of the epidermis, we see this stratified squamous tissue, but really, stratified meaning many layers. We can see they're flat. But if we go to the basement layer or toward the basement or the base layer, we do see they are kind of cuboidal. So, really, we have kind of cubes becoming squashed or cuboidal becoming squamous, oftentimes due to dehydration, which is a natural occurring event. So the deep layers of the epidermis, the skin, they're going to have very hydrated, very fresh new cells. And as they age, more cells are born at the basement here, and they push up and push up. And as they push up and they're aging, they get dehydrated, just like humans. As we age collectively, our systems become more dehydrated. So by the time the skin cell, the epithelial cell, which we call a keratinocyte, by the time it gets to the surface, you can see it's very thin and very flat and very squamous-like. So at that point, and in the skin, this process takes anywhere from 28 to 35 days. So like 4 to 5 weeks, you can get from a newborn baby keratin cell to an aged dying keratin cell, again, about 4 to 5 weeks. 4 to 5, not 45. Hopefully not 45. You'd be accumulating a lot of skin. So it's a hypomitotic. Then we have hypermitotic, which would be, having fresh layers of skin, every week or something instead of every 4 or 5 weeks. So anyway, that's an example of stratified squamous tissue, as well as a little mini discussion on epidermis. All right, so let's see. Some of our organs and tubes are going to be lined with epithelium that has cells that are more cuboidal in appearance collectively. And again, uh, we can modify these shapes by calling them simple or stratified. So simple means one layer. Stratified means many layers. So this simple, and then whatever the shape is, so simple cuboidal or simple squamous or simple columnar, that tells us that we have one layer of cells. So simple squamous would be one layer of flat cells. Um, so not very helpful for protection. We would see simple I know I'm backtracking a little bit, but we would see simple squamous in an area where we need rapid transfer of gas. So we would definitely see this in the lungs, in the deep lung tissues, in what we call the alveoli or the air sacs. So the simple squamous we find in the air sacs of the lungs, one thin layer. Stratified squamous, as I said earlier, many layers of flat cells. We would find this in the epidermis. Simple cuboidal and stratified cuboidal, we find these in a lot of areas where we need mucus and hydration. So maybe some glandular areas we might find cuboidal. And then columnar, those give us a little more thickness. We usually don't see stratified columnar, so we'd see something called pseudo-stratified columnar. So it appears like there's many layers of columns, but really it's just kind of some modified columns smashed in with some other columns. So they call that pseudo, meaning appears to be but isn't stratified columnar. Okay, no problem, Robbie. Thank you. Yeah, if you're having audio issues, you certainly log off and log back in. Let's see. And again, I am recording, so if push comes to shove and it's giving you issues, um, you can always rewatch it. Okay, so one thing, simple columnar and stratified cuboidal, these would help with thickness and maybe a little bit with protection. Uh, let's see. Pseudostratified, I want to mention a couple things with that. We do have cilia. That's one of our possibilities when it comes to cell features. Remember, cilia. Generally, we would see these in the respiratory system. Cilia help a lot with moving debris around. So, if you have a buildup of debris, um, or to prevent a buildup of debris, the cilia are going to be active on the surface of the lumen. And by the way, that's a term I wanted to mention last week. I think I might have forgot. So I'll mention it now. We'll see it again really throughout the entire semester, but it's spelled Lumen, lumen, Lumen. And a lumen is the kind of that negative space, the inside the opening of a tube. So when we look at a tube, like a hose or whatever, even a pen or, the inside of the tube, the negative space, that's called the lumen, 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 lumen. So the epithelium lines the tube. So the surface of these epithelial cells is going to be what basically makes the lumen. So the lumen of a lot of your respiratory tract is going to be like, kind of layered with these cilia. They're like nose hairs, basically. So pick your nose. Inside of there are nose hairs. Those are in essence giant cilia. So those little hairs lining all of your nasal cavity, they go into the sinuses. Your sinuses will be lined with the pseudostratified columbar epithelium with little cilia. Your whole nasal cavity, until you get back into the pharyngeal area, the back of the throat, then we start to lose those cilia and it's more of a smooth surface. And then we get down into the trachea and head over to the bronchi. We'll see when we get to the respiratory system, we do have a little bit more action in regards to the presence of cilia. So anyway, um, again, tissue is not real exciting. I don't want to spend too much time on it. I've probably spent enough time. All right. So, oh, by the way, real quick, transitional, this is a unique epithelium. Transition means changes. So transitional epithelium can go from a very thin, it can go from very thick layer to very thin layer, depending on what's going on. We see this a lot with the urinary bladder. Okay, so the bladder, when it's empty, is going to be thicker walled. And when the bladder fills up, the lining becomes thinner. So they call that transitional epithelium. All right, so let's keep her moving. Oh yeah, and if you haven't done them already, or if you did do them, your packet had some tissue identification. You definitely want to watch the keys video for that, but also my lecture video on tissues will discuss some of this as well. So I'm not going to spend too much time on this. We're going to keep her moving. Oh, there's a term keratinized, by the way. Keratinized means hardened. So non-keratinized means it's not hardened. Non-keratinized, the mouth, esophagus, vaginal wall, the cervix, those would be non-keratinized stratified squamous. Whereas the skin, the epidermis, would be keratinized, meaning the superficial cells, the surface cells have hardened. And what this is basically when a pap smear is done, what they're looking for is keratinization. So hopefully they don't see this on a pap smear. Hopefully they see something more like this. So that should be non-keratinized. Yeah. Let's see. There's that transitional glandular. Let's see. This talks about different types of glands. We have what are called exocrine, and exocrine excrete a substance, so like sweat gland into a duct. So like sweat glands, oil glands, tear glands, earwax glands, digestive, like, enzyme glands that are spritzing into a tube. Those are all exocrine. Whereas an endocrine gland is going to be secreting its hormone right into the bloodstream. All right. So that's it for epithelium. Connective, we're going to go quick on this. Connective again, it's deep to epithelium. It's going to be cells in a matrix. We see different types of connective tissue, fibrous. So it's going to have a lot of fibers in it. Some are dense, some are loose. So dense means lots of fibers, loose means not very many. So the connective tissues, you're thinking like tendons and ligaments, things like that. Oh, adipose is on there, so fat. Three other types, bone, cartilage, and blood. Okay, so bone is a type of connective tissue, cells in the matrix. So we'll talk about that today. It's more specific coming up, as well as cartilage. And then, of course, blood is considered connective tissue. All right, and then this just goes through some of the different the details. Oh, by the way, reticular connective tissue usually involves some sort of blood organ, like the spleen. So you'll oftentimes see red blood cells. That's what these little kind of purplish red circles in here. There's some more red ones over here. So usually if you see a bunch of red cells with fibers scattered throughout, that's probably reticular connective tissue. Because as you can see, there's no blood cells in any of this other, you know, you got collagen bundles. You know. But yeah, red blood cells scattered all over the place with some fibers. That's always reticular. Hey, we'll keep her moving. Bones. We'll talk about this today coming up. Spongy bone, cartilage. Oh yeah, and again, we'll talk about this a little bit today. Blood, we spend a time on that. We do a lab on blood typing coming up here in a few weeks. So I'll talk more about blood. But again, remember, connective tissue, cells, and a matrix. The matrix for blood is going to be plasma. There's a nice microscopic view of blood. See all the circles are red blood cells? And then the white blood cells are going to dye more of a purple color. the dye picks up on the nucleus. So red blood cells don't have a nucleus. That's why they're not purple. Let's see, types. Oh, so that's it for connective tissue. Then we get to muscle tissue, skeletal, smooth, cardiac. So again, skeletal muscle. We may touch on that today. If not, you'll want to watch the muscle video. And next week at the beginning of lab, I may spend a few minutes talking about the muscle system before we get into dissecting. We'll see. And then smooth and cardiac, again, we'll spend time throughout the semester talking about those. Smooth are all the tubes of the body. And cardiac, of course, is the heart. That leaves us with nervous tissue. And again, next week, we're going to start in on the nervous system. So I'll talk a little bit about these three. Brain, spinal cord, and nerves are the main components of the nervous system. Nervous tissue comes in has two different cell types. The neuron, which I'm sure many of you have heard of, this is what conducts the information, the electricity. This is what's going to contain a lot of the info that we're storing, a lot of memory and things like that. And neurons are around as long as you are. So unless you destroy one, and then that's it. They don't regenerate. Whereas these guys at the bottom, neuroglia, they're the connective tissue, if you will. They're not really connected. They're still nerve tissue, still nerve cells, but they're kind of like connective tissue in that they bring the neurons together. So outside of the neurons or around the neurons is going to be nerve glue, neuroglia. And these neuroglia cells, are what they call glial cells, are capable of mitosis. So there's a neuron there, and then all of this negative space is neuroglia. All right, we made it really to our first body system. I know those of you who have completed your Unit 1 assignment as well as the Unit 1 McGraw-Hill activities have already been exposed to the skin as a body system. So, but for us collectively, as a group, this is our first introduction to a body system. So, yay, we made it. So up to this point, it's okay. So for sure, one of the a final exam questions, because as I've been writing the exam and prepping your study guide, one of the questions is body kind of organization. So you need to know the smallest to the largest regarding organizing all of this stuff. So you need to know that chemistry and like atoms are the smallest in chemistry, and then cells and tissues and then organs and then organ systems and then the organism. Right, so you need to know that kind of building of who we are as a complete organism. So again, we start at the smallest level, right? That atomic level, that chemical level, and then that cellular level, tissue level, organ level, and now organ systems. So we're at our first organ system. We finished chemistry, cells, tissues, organs. Organ system is now integumentary system. So the organ system, integumentary. The organs of the integumentary system are going to be the skin, the hair, the nails. Then the tissues of the integumentary system are going to be some epithelial tissue called epidermis. We'll have some connective tissue called dermis, as well as adipose. We'll see a blood supply, we'll see a nerve supply. The different types of cells of the epidermis we call primarily keratinocytes, melanocytes, and then there are a few other tiny amount of specialized cells, Langerhans cells and Merkel cells. But for the most part, the epidermis cells are going to be made up of keratin and what are called melanocytes. So keratinocytes and melanocytes. So again, we've got the organ system, integumentary. We've got the organs, skin, hair, nails, and then we've got the tissue. And we're going to have epithelium and connective, and then part of that epithelium and connective are the cells, which are specific to the skin, called keratin and melanocytes. So And then we get into the dermis a little bit, the connective tissue aspect, and then that pretty much concludes your skin lecture. So it is the largest organ of the body. And again, it's made up this of the skin and its appendages, which the appendages are the hair and nails. Two primary layers, epidermis and dermis. We also see this term cutaneous. Anytime you see cutaneous, it has to do with the skin. All right, again, two primary layers, epidermis and dermis. There's another layer called the hypodermis, which is below everything, and that's primarily comprised of adipose tissue, which again is a type of connective tissue. Thin skin has hair and a smooth surface, so that's most of the skin of the body. Thick skin is going to be the palms of the hands and the bottoms of the feet. No hair there. And we look at the skin, we see the epidermis being that more superficial layer. We see all these stratified squamous cells, and then ultimately they become keratinized or hardened. Then we see the dermis deep to the epidermis containing all of this blood supply, and there's a collagen fibers providing support and strength and durability. We also see what are called elastic fibers, which provide flexibility. So again, we see collagen in the dermis is going to be for strength and durability, whereas elastin is going to be for flexibility. Again, both protein fibers. All right, so here is an example of some skin. Again, notice we don't have any hair there. So these are going to be your thick skin and your thin skin. We're going to focus more on the thin skin because this is collectively what we see a lot more of. Oops, back it up. There you go. There's your thick. Oh, by the way, we see both epidermis and dermis, and where they meet, we have what are called little dermal papillae. A papilla is a bump, so you can see these bumps. This would be the what makes up the basement membrane here. Okay, so epidermis, dermis. See the same thing over here. Epidermis and dermis. Notice the thickness. Thin skin, thick skin. Thicker skin, is you're going to have a lot more friction, right? The palms of the hands, bottoms of the feet. There's a lot more, not just friction, just exposure to surfaces, creating friction, needing more layers. All right. Notice too, all the way you have the dermis here and then the hypodermis down here. Yellow oftentimes represents fat, so you can see the adipose down here is yellow. Nerves are also represented as being kind of a yellowish cream color, so they're typically kind of layered in fat. So anyway, here's more epidermis, dermis of thin skin. Here's a hair follicle. Couple of items real quick here. We've got a couple of oil glands attached to the hair follicle. So those are called sudoriferous. So oil glands, they keep the hair follicles kind of hydrated, I suppose you'd say, somewhat lubricated. When the body's dehydrated or we're lacking specific oils, it can make the hair dry for sure. So again, going back to some of our discussions on products that we consume that can dehydrate the body, or products we consume too much of. So if you eat a lot of oily foods or consume a lot of oily foods, you might have more oily or greasy hair. If you're not consuming enough of the right oils, or in addition to consuming a lot of dehydrating, a lot of sodium or alcohol, that's gonna potentially make your hair and skin more dry or dehydrated. Same with these sweat glands. These sweat glands, you can see they originate down here uh, in that hypodermis region. Yeah, sweat glands, these exist to basically kind of help regulate body temperature. So we'll see something next semester called evaporative cooling, where the sweat comes out, it kind of lands on your skin, and then when it evaporates, it takes some of that heat with it. So evaporative cooling occurs when we put sweat or water on the body. That's why even just putting a wet cloth, and not don't leave it there, but put a wet cloth and then remove it. Sometimes just running some water on the body, some cool water, and then it evaporates. Then it can pull heat away from the body. Yeah. So anyway, oil glands, sweat glands, and then we can see different types of nerve cells and nerve tissue. Kind of plug it in. You're also learning your first muscle here. This is a muscle connected to the hair follicles. It's called the erector pili. Hey, erector pili. Pili is like pelo in Spanish. It's Latin for hair. And then erector, of course, has to do with being erect. So the erector pili muscle uh, makes the hair stand on end. So um, again, a body response to stress, whether it's temperature stress or psychological stress, whatever it might be. Yeah, correct. Yes, goosebumps. Absolutely, Robert. Yes. So goosebumps will be created by this erector pili. Nice. So, yep, in response again to perceived stress, actual temperature stress. Um, yeah, so that's your first muscle. Real quick, we'll learn a few more today and next week, but and throughout the semester. But muscles are named oftentimes. Well, they have a lot of naming systems and conventions for muscles, but one of them has to do with the action of the muscle. So some muscles are named for what they do. This would be an example of that. So the name erector pili tells us what the muscle does. Whereas like some muscles like the biceps brachii. Brachii means arm, so it tells me it's where it's located. And then biceps means two-headed. That just means it has two what are called origin heads, tendons. So the head means the tendons. So two heads or tendons at the origin spot. So it kind of tells you about the structure and location. So it doesn't tell you what it does. Some muscles are named for their shape, like the rhomboids or the deltoids. Delta is a triangle, so the deltoid muscle is like an upside down triangle. The trapezius muscles, they're like a trapezoid shape. So again, muscles have they're named for various reasons. They're named for the shape of them, for the action or what they do, like erector pili. We have muscles called adductor groups. Some are named for the direction of the fibers, so like the oblique muscles of the abdominal area, the rectus abdominis, so they're erect. So anyway, muscles. So that's what I mean. We can kind of discuss just in this moment. We've hit blood, nerve, muscle, and skin all in one little micro discussion. So again, it's important. I know we take this course system by system by system. It seems like it's kind of compartmentalized, but again, I want to I'll continue to emphasize that everything is connected, and you're already seeing this. No, I mean even your digestive tract is connected to this because you're what you consume and your respiratory tract. So breathing and eating, that ends up in the bloodstream, which then ends up being delivered to the skin and the cells of the skin. So the cells of the skin consume what you consume. So when you consume the proper vitamins, minerals, and fluids, get the proper oxygen intake, then you're going to see the skin cells receiving the nutrients they need. And so oftentimes the health of the individual It's clinically speaking and personally, your health, your friends and family's health, and certainly your patient's health at the clinic. A lot of times we can tell a lot about what's going on internally and what they're doing with their lifestyle and functionality day to day by the appearance of the skin. So if we have very blotchy skin, very dry skin, and and is it just, we'll see indicators like maybe the elbow or the knuckles, are extremely dry, like sandpaper. That's an indicator potentially of some systemic dehydration. So we want to get on that before it gets to being, the palms of the hands are super dry and the mouth is super dry and the mucous membranes down below are super dry. We want to prevent that. So, being hydrated and being aware of, sodium and potassium intake and those types of things are important. So again, we see it clinically speaking, under the eyes, that area there is directly linked to the kidneys. And again, it's all about hydration. So, it meaning life, survival, homeostasis. You have to be hydrated properly. And the kidneys are the main organ of regulating hydration, water balance, fluid balance, electrolyte balance. All of that is done by the kidneys. And so, if we're dehydrated, oh, and the kidneys are also your number one organ for stress management, along with the adrenal glands. They work together. So, under the eyes, that area, if it's extra dark circles under the eyes, very puffy. I've seen some patients there and folks that have, like a half inch of a pouch of puffiness under the eyes. This is stress on the kidneys right off the bat. If I see that, I know that person is extremely stressed in the kidney realm. And again, and then we know what the kidneys do. So then we can kind of work backwards. We need to discuss caffeine intake. We need to discuss sleep because that's when the kidneys repair and regenerate. We need to discuss hydration, alcohol consumption, uh, caffeine, which is a diuretic, sodium consumption, um, their job, like what do they do every day? Are they breaking their back, if you will? Do they have a lot of financial strain? That's like low back and kidney issues too. So, I mean, how are we coping with stress? How are the kidneys affected? We can see that in the skin under the eyes. So, the mouth and the lips, tell us a lot about, again, like digestive health and hydration and proper oils and things. So, the you know acne, pimples, boils, cysts, those are all indicators of a sluggish lymphatic system, especially extreme acne, pimples, ingrown hairs, things like that. We think, oh well, our surface is dirty and that's why we're getting these. No, 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 no. These are expressions of what's going on internally. So again, and again, of course, hormones affect that, but hormones are made from what you consume. Um, so if you're consuming the right things, then your hormones have the right building blocks, and so the expression of the behavior of the individual, is going to be more balanced. So again, these are things with the skin that we're definite, definitely considering. So you don't have to be a dermatologist, you don't have to be a skin specialist to understand the very basics of what's going on with the skin, and how it's affected by what we consume or don't consume. And then it also includes what we choose to put, on our skins on our skin, whether it's, types of deodorants, types of lotions, gels, oils, whatever it might be. Just remember that if your skin is dehydrated and you're putting lotion all over it, it's going to feel slick, but you're really not fixing the issue of dehydration. You don't hydrate from outside, you hydrate from within. So, but that comes from outside. So you have to drink water to get it in, so then your skin and the rest of your organs have what they need to function properly. And your heart and your brain and your kidneys need more water than any organs, including the skin. So they're going to keep the water, and so have when you're expressing dehydrated and extremely dry skin, that's telling you that you have, again, systemic, meaning body systems are dehydrated. So you need to hydrate. All right. But you're not sick, you're dehydrated probably. And chronic dehydration leads to illness. So anyway, um, I mentioned these keratinocytes. These are the primary cells of the epidermis. Melanocytes come in a second. Probably 90% of your skin is keratin, the epidermis. All right, anyway, melanocytes contribute to filtering UV rays. Then we have some dendritic cells that help with immunity and tactile cells that help with touch. And here's a illustration of some of these cells. So again, it's primarily focused on the cells of the epidermis, and that epidermis is connected to the dermis at this dermo-epidermal junction. And again, this is also called the basement membrane or the basement layer. You can see down here in the dermis where the nerves are, there's a nerve ending that plugs into the epidermis and creates this tactile cell. Doesn't create it, it works with it. So again, we don't necessarily have blood or nerve in the epidermis, but we do have cells that are linked to the nervous system. Now, when it comes to blood supply, blood is bringing nutrients and taking away waste. So down here in this basement area, they also call this the germinating area. So this is where newborn epidermal cells are going to be found. So we do feed the epidermis from the dermis. Okay? So the underlying tissue, the dermis, has a blood supply that feeds these cells of the epidermis. You guys doing good? Okay, good. We'll move on from this. Do you need to know the layers of the epidermis? I don't know. I think it's important to recognize the term stratum. Stratum means layer. And then maybe knowing the lowest, the deepest layer and the most superficial layer, you'll probably be good. I think if you recognize basal means base. So, what's the deepest layer of the epidermis? The base layer, the basal. All right. And then I'm going to move on from those. And then the most superficial layer is called the corneum. So stratum corneum is going to be the kind of hardened layer on the out. So that's what we see, stratum corneum. That's what all this is. Yeah, so I would definitely say that you should probably know at the very least those two, stratum basal and stratum corneum. All right, 28 to 35 days. And then the dermis is the true skin, if you will. Again, this is where we're going to find all of the action. Erector pili, blood supply, nerve supply, all of that good stuff. All right, let's get out of skin here and move on. I know that was kind of abrupt. Well, that's the way we like it. Get it, just rip the band-aid off, right? We're done with skin. All right, so that's unit 1/module 1, whatever you want to call it, or module 1. Unit 1, 2A, 2B, and 2C. Okay, so let's move into module 2. Many of you already have, so that's good. I don't want to spend too much time. I'll probably try to do about maybe 20 minutes on skeletal and 30 minutes maybe on skeletal and 20 minutes on muscle. All right, so skeleton, first thing we always do is start with the cells and the tissues. So let's get into that. But before we do, let's take a quick peek at why do you need bone? Well, certainly for support, keeps all of your uh, muscles and organs upright, your body upright. It also protects, so like your brain and spinal cord protect, your rib cage protects. We certainly get movement because of bone. Joints are formed by two bones coming together, make a joint. We can store minerals as well, yeah, mineral storage. Well, that's true. Hopefully, the bones are very strong. It takes a lot of tensile. They have a lot of tensile strength, so the amount of pressure to break a bone is pretty high. So unless the bone is porous or we're young, younger folks, their bones haven't developed entirely, so they may be a little. They're more flexible, so actually they're probably at less risk, really, of breaking. But I mean, really, and so yeah. Oh, and by the way, usually when somebody does fall and break a hip, usually it's an elderly person, and it's usually an elderly female. For some reason, and we'll talk about it next semester in more depth, females have, as they age and they lose some of their estrogen levels, or their estrogen levels go down, bone density also goes down. So sometimes the hip bone, which we call the head and neck of the femur, which is your thigh bone. So your femur, your thigh bone plugs into your hip, and sometimes that femur head and neck will get real porous and brittle. So usually what'll happen is that will break, and then the individual will fall. But anyway, so grandma doesn't really fall and break her hip. Her femur breaks, and then she falls. But anyway, so yes, movement is important, and trying to maintain movement so we don't fall is important as well, certainly. Mineral storage, again, we're thinking calcium and phosphorus primarily. And then hematopoiesis, this is a physiological phenomenon. Poiesis means production or processing. So producing, hemato relates to blood. So blood cells are produced in bone. So that's kind of cool. That's again a little more physiological stuff. There is a on the Padlet board, there might be a little bit of something on that. But yeah, calcium homeostasis and blood cell production. All right, here's a rundown of a bunch of basic bones. We can organize them, and these go along with your packet. So when you're working on your module 2/unit 2 assignment, you're going to see these terms. A long bone is a bone that's certainly, just like it sounds, it's longer than it is wide. A short bone is kind of boxy shaped, roughly similar in appearance to a cube. A flat bone is just that. It's going to have kind of thin, like your ribs or your scapulae. A lot of your skull bones are flat. Irregular bones are going to be like vertebral bones. They're going to have kind of oddball shapes. They don't really fit into any other category, so we call them irregular. And then a sesamoid bone is a bone that doesn't really articulate with other bones, so they call it a floating bone. So sesamoid bones are floating bones. So the kneecap is considered a sesamoid or the patella. So here are some examples. Here's the humerus is a long bone. Carpals, so basically the legs and arms, appendages are long bones, including the fingers and hands. Short bones are going to be carpals, so wrists, as well as ankle bones or tarsals. Irregular are your vertebral bones. Flat bones are like the sternum and the ribs, scapulae or shoulder blades. And then sesamoids, we have a named one called the patella, but we also have some that aren't contained in, by the way, there are 206 bones, 206, including the patella. And there are really more than 206. Like each tooth could be considered a bone, but we don't count that. We don't count those as part of the 206. We just count the mandible and maxilla that contain the teeth. And then oftentimes in the hands, especially kind of in this area, sometimes in the feet, you might have a sesamoid or a bone that's kind of grown in. So anyway, 206 is not the absolute number. That's the general number that we use when discussing how many bones are in the body. All right. So anyway, those are the different bones. We have uh, tissue types of called compact and spongy. Compact bone is more superficial. A compact bone is going to be out here, kind of around. Now it's not around the bone. Periosteum, which I don't know. There it is, right in the middle there. Periosteum is kind of covering the bone. Well, not kind of, it is covering the bone. And then just deep to periosteum is going to be compact bone. And then deep to compact bone is going to be spongy bone. They also call it cancellous bone. Trabecular too. So really it's got three names: spongy, cancellous, and trabecular. And just keep trying to keep on track here. All right, so when we look at so let's take a peek at a long bone. These are terms again that you'll see in your packet, but we have the what's called the shaft of the bone. That's called the diaphysis. So you're going to have one shaft, and then the ends of the bones are called epiphyses. So notice the diaphysis, is, that's singular. Epiphyses, es, means it's plural. You could have one epiphysis, and we'd call it the proximal epiphysis, would be the end of the bone that's closest to the insertion of it onto the body. And then the distal epiphysis is going to be furthest away. So when we look at the humerus, you have a proximal epiphysis up here and a distal epiphysis down toward the elbow. In fact, that this elbow region is going to be the distal epiphysis of the humerus, and then the proximal aspect of the ulna. All right, so epiphysis, those are the ends of the bones. Okay, so epiphysis. Now, the ends of the bone are not going to have a lot of compact bone. They're going to have some, but primarily the epiphyses, as you can see here. By the way, this is an illustration, and on the right, we have an actual image. Okay, so again, the proximal end is at the top. And you can see they've opened up the bone and given you kind of what we'd call a lateral, kind of, you have a lateral view of the bone. So the distal epiphysis region and the proximal epiphysis region, as you can see, it's mostly spongy bone. Then when we look at the diaphysis or the shaft of the bone, we can see there's no spongy bone there. This is primarily going to be a bone marrow cavity. So this is a marrow cavity in here. Bone marrow, by the way, is yellow once we're done growing. So, by the time you're 18 to 25, the marrow in your long bones turns to in the diaphysis turns yellow. Now, before that, so when you're born, up until you're 18 to 25, the bone marrow in the long bone shaft is going to be red. Okay, now remember, one of the functions of bone is blood cell production. So red bone marrow relates to red blood cell production. So red blood cells live 120 days, so you're throughout your life. So you're constantly producing them. So after you're 20 to 25, 18 to 25, red blood cell production is coming from spongy bone exclusively, not really much in the way of this marrow bone. The marrow cavity becomes yellow, and you can see over here in the illustration. And yellow is fat, so this is converted to fat. So again, bone marrow is primarily yellow in adult life in long bones, but before then it's red, so it converts from red to yellow after you're done growing. Why is that? Well, you need a lot more energy when you're young and you're growing. So you go through more red blood cells. They transport oxygen. So there's just a lot more need for red blood cells. Anyway, we also have in the ends of the bones this epiphyseal line. This line is a remnant of what used to be an epiphyseal plate, which is made of cartilage. So when you're in the womb, the skeleton's primarily cartilage, and then as we grow, the bones grow toward the ends. So they grow like this. So as we they grow toward the epiphyses. So the primary bony growth center is going to be, so the primary ossification center is going to be in the shaft of the bone. Secondary centers are in the epiphyses. And so basically they just kind of grow toward the ends. The bone grows toward the ends, and then it kind of comes together and creates this line. But in between, you're going to have what's called a growth plate. It's kind of a cartilaginous disc in here, and that'll seal up and become hardened, again, usually by the time we're 18 to 25 years old. In younger kids, that are still growing, you're going to see more of a disc there. So it's important to understand that if we do have a fracture in an epiphyseal area in someone that's not done growing, that could be problematic. So, because again, we don't want to disrupt the growth plates during growth. Um, so anyway, something to keep in mind. Oh, also to notice, we have this blue color here. Blue in the body, typically in illustrations of anatomy, blue is going to be indicative of low oxygen. So we have low oxygen here. We also see this as cartilage. So blue is usually going to also be used when we're trying to represent cartilage. So you could conclude then, hopefully, that cartilage is avascular, meaning cartilage does not have a blood supply. So again, in the body and illustrations, we represent low oxygen as being the color blue. So when you see the color blue, it's indicative of low oxygen, a low blood supply. And in this case, we see cartilage. So the ends of the bones are going to be cartilage, and cartilage, a type of cartilage, which again, there's no blood supply there. So it's difficult to repair cartilage. Oftentimes it requires a surgical procedure. All right, so guys doing good? All right. So those are again some of the terms you'll see. They're in your packet. Oh yeah, I wanted to mention, I know you probably know this, but I want to remind you when you look at my PowerPoints or my slides, uh, okay, so at the bottom, you can see at the bottom, there we go. At the bottom of them, I have some notes. So, you might find some more details as you're filling out your stuff there. There you go. See, my kind of my lecture notes there. I don't know if you guys knew that or if I had mentioned that. I think I did, but if not, there you go. See how they don't show up on here. All right, so that's a long bone. A flat bone looks a little bit different, not that much different. You're not going to have a shaft with a flat bone. Um, so you're just gonna it's gonna look like this. So you're just gonna basically gonna have periosteum, a little bit of compact bone out here, then you have mostly spongy bone, and then more compact bone, and then another layer. Now, next week, when we dissect the brain, we're going to see there's the brain is surrounded with a specialized tissue called the dura mater. And the dura mater is going to be kind of connected to a degree with the inside lining of the skull bones. So right along in here is where that dura mater is going to be basically kind of adhered to some degree to the inner wall of the skull. And out here, skin. So you're going to have skin, a little bit of muscle, not much fat, and then you're going to have periosteum, a little bit of compact bone, some spongy bone, and a little bit of compact bone, and then dura mater in the brain. So not a lot of you know, from out here to the brain, there's not a lot of protection there. All right. Ba-ba-ba-ba. Oh, the mate. So again, tissue-wise, bone is connective tissue because again, we have extracellular components. So that's the matrix, and we have cells in a matrix. The matrix of the bone is going to be hardened. Most of the time, a matrix is going to be more fluid. So the primary composition of the matrix is going to have your inorganic salts. So calcium and phosphate. So the matrix is primarily calcium and phosphate. We also have traces of magnesium, sodium sulfate, and fluoride. Now, calcium is important for muscle contraction. So, whenever we need a muscle to contract, we're going to use up a lot of calcium. So, it's good that the bone has basically the skeleton is a giant gas tank full of calcium. And calcium's the gas we need to get a muscle to contract. Ground substance. So basically, the matrix is a bunch of cells, primarily uh, calcium, as well as some collagen fibers and what's called ground substance, basically glue, and keeps everything adhered together. Now, the cells inside of the matrix are called osteoblasts, osteoclasts, and osteocytes. So remember, we're dealing with an organ called the bone. And that organ is made up of tissue, and that tissue is called connective tissue. And that connective tissue is made up of cells in a matrix. The matrix is going to be primarily inorganic salts, calcium and phosphate. There'll be a little bit of glue, which in the body we use sugar for glue primarily. So that's why you see that word polysaccharide in there. That means long chain. It's starch, basically. Um, Collagen fibers give strength. Pardon me. All right. Anyway, so that's the matrix part. And then the cells that are in the matrix are going to be blasts. Osteo means bone, of course. So osteoblasts are cells that build bone. So these are usually a little younger, newer, fresher. The osteoblasts are bone builders. Lots of bees. Blasts build bone. These guys, these are the chiselers. They're going to kind of form the bone. So the blasts are building the bone. The clasts come in and kind of chisel it out and make sure it's nice and smooth and rounded. When we have bone spurs, it means the blasts are out and doing the clasts. So again, if clast activity is minimal and blast activity is maximal, you're going to end up with excess bone. If it's flipped, blast activity is minimal, clast activity is maximal, then you end up with porous bone. That's why bone and calcium and cell homeostasis is so important because if I have too much osteoblast activity, I can get bone spurs and bony growths, bunions. If I don't have enough blast activity and I have too much clast activity, then my bones become porous because the clasts chisel away bone. So we need clasts to be active when we need calcium. So when muscles need calcium and we don't have enough in our diet, then the body will start, clasts will be activated. They'll start chiseling away at bone, which is going to release calcium into the bloodstream. So if we don't get enough calcium in the diet, which is kind of a process, then it could lead to bone density loss because your body will chisel calcium out of your bone because your heart needs calcium to contract. Okay. So anyway, blast build it, class chisel it. And they're always working together. When you consume foods that are high in calcium, you consume any calcium, that calcium is going to get delivered to the muscles and the bones. They're both going to store it. The bones are going to store it. The blast activity is going to increase when we give them calcium to build the bone with. And then when we need the calcium, we can ask the class to chisel some out for us. But we do need to replace it. And that's why, again, a balanced diet is so important. Carbs, proteins, fats, vitamins, minerals, water. Calcium falls into the mineral category. You need appropriate amounts of calcium. All right, osteocytes. So they're just showing you a bunch of different types of bone again. You've got the spongy bone, trabeculae. This is kind of that lattice work or those little kind of bridges that form the spongy aspects. You see, there's a lot of blood supply. These are called this is called the central canal, and this is going to be uh, um, more like a kind of like a perforating canal. It's like a perpendicular canal, so central and perpendicular. They used to call them, you'll see, still see Haversian. Haversian always has to do with the canal system inside of your compact bone. We have lamellae is the layer, lamellaire. And then these osteocytes, they live in a cocoon called a lacuna. So again, some of this terminology is a little weird. Just remember, lamella is like a layer of bone. So I say lamellaire, and lamella is a layer. And then a lacuna is like a cocoon. Okay, a cocuna. And that's where the little cocoon or the lacuna is where the osteocytes reside. An osteocyte is neither an osteoblast or an osteoclast. An osteocyte is a mature bone cell, so it's basically just providing structure at this point. Now, this can become a blast or a clast. Yeah, under, when we need bone chiseled or bone stored, these osteocytes can activate. Okay. So anyway, some of your bone terminology there. There's those, again, lamella. Those are the layers. Lacuna, that's the cocoon where the osteocyte lives. Canaliculi, that just means little canal. Canaliculi. So it's just a little canal. You see this right here? Those are little canals. Canaliculi. That's all that means. All right. And again, we're looking for, we're delivering nutrients. We're taking away waste, but we're also taking away calcium and other groceries too. All right. So again, nutrients and waste. This is just showing how we direct stress on bone. By the way, when you put stress on a bone, it's going to activate osteoblast and clast activity. So stress on bone will activate blasts and clasts. So when I put stress on a bone, and I don't mean stress it like hey, bone, you owe us money. Not that kind of stress. It's like physical stress, right? So physical stress on bone is going to cause osteoblasts to want to provide more support. So they're going to start building bone. Well, where are they going to get some of the material to build that with? It's going to come from the class. So the class will chisel from an area that maybe isn't receiving the stress, and they'll remove some of the bone and they'll deliver it and give it to the blast to build bone where there is stress. So then I could have a bone spur on an area where there's a lot of stress, and then I could have porosity or porous bone where there isn't enough stress. So again, this is why a sedentary lifestyle is not a good idea. No different than a hyperactive lifestyle is not a good idea. So we have to balance out like how much stress are we putting on bone. If we don't put any stress on the bone, it's just going to kind of wear away. Eh, If you put too much stress on it, you'll get excess bone in one area and wear away in another area or porous. All right. So anyway, a lot of blood going to bone, in and out of bone. By the way, there are holes in bone called foramen, Foramen. Okay, holes in bone called foramen. So that's how we get blood and nutrients in, and other waste as well as calcium and other items out of the blood. There are holes in bones. Oh, and I'd already mentioned this about the red marrow and the yellow marrow. You can read that. Cartilage, again, it's fairly flexible. It's much more flexible than bone. So when you're developing in the womb as a fetus, your skeleton is more soft than it would be, at a year old. So mom delivers a bag of cartilage. It's a lot easier than a bag of bones, right? So anyway, as soon as the skeleton, the fetal skeleton starts to harden a little bit, 32 to 40 weeks, mom's gonna start getting signals, and baby's gonna start doing its thing, and mom's gonna start doing her thing and prepping basically for delivery. We do have three types of cartilage: hyaline, some say hyaline or hyaline, elastic, and fibro. Hyaline cartilage is associated with the ribs and the sternum. Elastic cartilage, thinking like the ears. And then fibrocartilage, probably thinking kind of in between the intervertebral discs. And again, for cushioning, shock absorption, that kind of thing. Here's the bone formation info. Again, I mentioned before, you've got this blue cartilage pellet, and then we start this primary ossification center in the shaft or the diaphysis. And we have the secondary centers you can start to see forming in the epiphyses. And then here's that growth plate or that epiphyseal plate forming. Yeah. And then eventually we're going to get these to fuse and they're having epiphyseal line and a little bit of cartilage left over for cushioning. You can look at these on your own. I'm just going to keep zipping through the physio plate. So this is all bone tissue stuff. So again, skeleton's fully ossified by 25 or so. Um, we can get decreased bone density as well as in strength. Pregnancy, nutrient deficiencies, illness, certainly osteoporosis. Exercise can counteract degeneration. Again, stress on bone builds bone. Stress on bone is a good thing. We don't want to overstress it, but we do want grandma and grandpa. We want them moving around. We want a little bit of stress to be put on their skeletal system, so they retain some of that bone density. All right, so where are we here? It's about 11. We got about 20 minutes. So I'm gonna zoom through a couple things, a skeleton, and then I want to talk a little bit about muscle, I think. I don't know. We'll see what happens. So skeleton, we can divide it into two categories, the axial skeleton and then the appendicular. Okay, so axial is going to be skull, vertebral column, and ribs. And then they call it the thoracic cage. And then the appendicular skeleton is basically everything else. So certainly the arms and legs, but also the shoulder girdle and the pelvic girdle. So this is a nice illustration showing you the difference between axial and appendicular. And is it a good idea to know all 206 bones? Well, sure. And it's not as intense as it might seem because 24 are ribs, um, geez, just fingers and toes. You've got 3, 6, 9, 12, 14, 20, 56 out of 206 are just fingers and toes. So that bumps you all the way down to 150. So you can go from 206 to 150 just by getting rid of fingers and toes. So that's pretty good. So now we're down to 150. Get rid of ribs, that's 24. So now you're down to 126. Um, And then let's see, wrists are 16, so that knocks us all the way down to 110. Ankles is 14, so that knocks us under 100. Now we're down to 96. Let's see. You see what so oh, vertebrae, you've got 96, you got 7, 12, that's 19, 24. So you got about 26 vertebrae. Some are fused. So that's 96, right? So now we're all the way down to 70. So we went from 206 to 70, and we just knocked out like 4 or 5 groups of items. So the rest of those bones are going to be the clavicles, the scapulae, the humeri, I don't know, both humerus bones, uh, the ulna and the radius, your two forearm bones. And then down here you had femur, tibia, and fibula. The tibia is your shin. That's the weight bearing, pardon me, bone. Fibula is going to be the non-weight bearing lower leg bone. Fibula is lateral to the tibia. And also the little ankle bones, those bumps on the lateral and medial portion of your lower leg, those are actually parts of your shin and your fibula. So you can see the tibia comes down over here is going to be uh, part of the tibia, and then over here is part of the fibula. So again, sometimes folks will break their ankle, but really they're breaking the fibula or the tibia. Usually it's the fibula, the lateral of the two, the non-weight bearing. Okay, and then again, we've got the pelvic bones, the ilium, the ischium or ischium, that's your butt bone, and then the pubic bone or pubis bones. Okay. And then the skull, that has several bones, so we'll look at some of those next. Yeah, the skull bone, you've got the, there we go. Okay. We've got the frontal bone, two parietal bones, and one occipital. Two temporals. So we've got one, two, three, four. Yeah, so we got another 4, 5, 6 bones just right away in the skull. Okay. And again, are you going to know these, memorize these forever? I don't know. I think it's probably a good idea to have a basic understanding of the names of the bones, especially the clinically relevant bone. You should know that this is the humerus. You should know the elbow is the ulna, and this is the olecranon, the ulna. You should know this is the radius. Okay? Know the wrists are the carpals. You don't need to know specifics, just know wrist as carpals. And then the hands are metacarpals, and the fingers are phalanges. That's all you need to know. Know that the shoulder blade is called a scapula. Know that the collarbone is called a clavicle. You've also got a little bone in the throat called the hyoid bone. Okay? Know your jaw is the mandible. Mandible. Maxilla is the upper jaw. And of course, your nasal bone. And then your ear holes, that's part of the temporal area. Okay. And the forehead is frontal, occipital. These are regions. So frontal region, parietal region, occipital region, temporal region. These are going to be parts of the brain next week too. So when we dissect the brain, we're going to look at the frontal, parietal, occipital, and temporal regions of the brain. So again, you can try to just memorize. It's just, it'll never work. It's really a matter of repetition and just daily working on connecting these terms because you've seen them all before, or at least a lot of them. Zygomatic, you saw that means has to do with the cheek area. Buccal has to do with the cheek area as well. So anyway, a lot of bones, certainly it can be overwhelming, but again, it doesn't have to be. You can just, if you're doing your McGraw-Hill labeling concurrently with your unit lab assignment labelings, I mean, you're getting exposed that way. And as you're doing it, touch your own body. Say, okay, this is the humerus. Where's my clavicle? Let's see. Oh, there it is. I can palpate my clav. We don't say touch, and we say palpate. Palpate the clavicle, palpate the scapula, palpate the nasal bone. So I would recommend doing that as well. I mean, as you're filling these out, as you're studying, bring in a friend, a neighbor, a spouse, a kid, your kid, if you're a parent, a sibling, if you have a sibling, a boyfriend, a girlfriend, heck, you could, I don't know about your animals. It's better to do it on humans because you're getting into human medical stuff. But yeah, find these items on yourself and then also someone else. That gives you the practice and say them out loud. And have them say them to you. The best way to learn something kind of long term, not just learn it for me and just to pass a test, but for long-term memory, is to teach it, to show it to someone. So if you have someone at home and you can show them or teach, don't even say the word teach because that could get your brain all weird. But trust me, you are all teachers. You're gonna be if you're work when you go to work in a clinic, you're teaching patients. Sometimes you're teaching the doctor. But anyway, my point is you could start this process of understanding because applicability of this is what's most important. You want to be able to, you could even have, your brother or sister or girlfriend or boyfriend or mom or dad or whoever, aunt, uncle, whatever it is, or whoever it is. I mean, maybe it is a whatever. Anyway, whoever it is, you can have them say, quiz you, all right, I've got an injury or this part of my body hurts. Oh, that's your humerus. Or, oh, I mean, you can do this however you want. If you're just doing it to get it done, then you're probably going to have a harder time remembering it long term than actually doing it to understand it. So I would definitely recommend recruiting somebody to be a little bit of a helper, someone you can kind of teach or facilitate an understanding of as well as you're trying to understand this stuff. If that doesn't work, just use your own body. Get an app. There are several apps for learning and understanding this stuff. But anyway, um, fetal skull. Oh yeah, these are called fontanelles. A fontanelle, you know them as a soft spot, but yeah, the clinical term is fontanelle. There's that hyoid bone I mentioned. It's kind of a floater. It kind of anchors a lot of your vocal folds and things like that. Yeah, vertebral column. Breakfast at 7, lunch at noon, and dinner at 5. Okay, so 7, 12, and 5. Most of you probably don't do that anymore. That's old boomer farmer stuff. But cervicals, there are 7 cervical. And by the way, cervicals are going to have 3 holes in them. So you can see this is a cervical because it has one, two, 3 holes in it. This is a cervical because it has 3 holes as well. Here's one. The other 2 are kind of on the side. Here's the second one. Second one's over here. Third one's over here. So is this a cervical vertebra? Yes. Why? It has 3 holes. One, two, three. Looks like a giraffe. Let's see. Thoracic, you have 12 of those. Those work in conjunction with your ribs. Yeah, we're not going to get to muscles. We'll just finish bone. We've got a few more minutes. But anyway, thoracic, 1 hole, medium-sized body. They look a little bit like a dog, almost like a pit bull or something there, maybe in the profile. See how that looks like a giraffe almost? But anyway, thoracic, these articulate with the ribs. And then finally, the lumbar, you have 5 of those. Those are the largest. They basically go from smallest to largest. Smallest body, middlest body, largest body. And 1 hole. Okay, lumbar, very giant body. And a lateral view, it looks like kind of like a moose head. All right, and then we have what's called the sacrum. It's 3 to 5 fused vertebrae. Okay, the sacrum. Sacrum articulates with the lumbar vertebra, number 5. By the way, we categorize and label these as first letter and then whatever number it is. So C3, C4, etc. T1 to T12, and then L1 to L5. So when we're charting on the clinical level, we're going to use all these clinical abbreviations, or you're going to be reading them. If a patient had some sort of neck injury at C4, you're going to know that it's associated kind of with this area of the neck. If it's C7, it's going to be down lower, kind of where that hump is in your neck. Yeah, right at the beginning of that hump. If it's like C1 or 2, that's way up here. C1, by the way, is also called the atlas. C2 is called the axis. So atlas and the axis. And you definitely want to remember those. Atlas C1, axis C2, Atlas C1, axis C2. How you remember them is in the dictionary, Atlas does come before axis. So one also comes before two. So Atlas is before axis in the dictionary as well. So that's kind of nice. T comes before X. There's the Atlas and the axis articulating with one another. By the way, this is a joint. A joint is any bone and any other bone coming together. There doesn't even have to be movement. It's just a bone and a bone coming together equals a joint. And a fancy word for joint is articulation. All right, so there's your vertebra. There are your vertebra. Wait, there are your vertebrae. One is a vertebra. There is a vertebra. There are your vertebrae. All right. Next up is the sternum and the thoracic cage. The sternum is going to be comprised of three parts: manubrium, body, and xiphoid process. Um, Ribs, you're going to have 12 pairs of ribs to go with your 12 thoracic vertebrae. Now, the first seven are what they call true ribs, first seven pairs. Each one has its own distinct cartilage insertion on the sternum, whereas pairs 8, 9, and 10 combine and have one insertion. See right here? 8, 9, 10. So these are called false ribs. Still worshiping these false ribs. All right. So anyway, three ribs, 8, 9, 10. And then the last two are floating ribs, 11 and 12. So you have five pairs of false ribs, 8 through 12. All right, sternum. And then the rib, again, we just did the ribs. There's kind of what they look like. So that's your axial skeleton. Skull, vertebral column, rib cage, sternum. The rest is appendicular. So we're pretty much at the spot where we can wrap things up here. So let's do it. We've got the shoulder girdle, which is made up of the scapula and the clavicle. So, right shoulder girdle, clavicle, scapula. And you can palpate laterally at the top of your shoulder area there. You can actually trace your clavicle and find it meeting up with the scapula and keep tracing it. And then you find the scapula. It goes all the way around. That's going to be this part right here, the spine of the scapula and the acromion process. So that connects with the clavicle. So if you palpate the clavicle, boom, then you feel the acromion process. Keep going on that hard bony ridge. That's going to be the spine of the scapula. Okay, so it's one kind of continual, I don't know, like a V, I suppose, or maybe a U shape. Okay. The other thing that's kind of cool about the scapula is it forms the socket for your humerus. So this forms your shoulder socket, the glenoid cavity. So glenoid has to do with the scapular uh, socket for the humerus. So they call this the glenohumeral joint. There's where the humerus plugs in here. Notice it's blue. Again, that's indicative of cartilage. We call it articular cartilage. Let's see. All right, upper arm bone is humerus. Lower, the forearm bones are called ulna and radius. And you definitely need to know the ulna makes up the elbow. Just remember the ul sounds. Ulna, elbow, olecranon. Hey, look at that. Olecranon is a fancy word for elbow, which is part of the ulna. So the L's have it, right? Ulna, olecranon, elbow. Okay. And it's going to be on the medial portion, okay? Pinky side. And again, if you're not sure on a test, just touch your elbow and palpate your elbow and trace it till it stops. And it stops right around here on the pinky side. And remember, when we're in correct anatomical position, the pinky is medial. So ulna is medial. The radius, and the ulna just does this, open, close. Radius is smaller. It's the lateral. You can find the radius easily. Just find your thumb and then come down your thumb. And then right there on your lateral part of your wrist, that's the radius. And then just keep palpating. It kind of disappears somewhere toward your elbow. Okay, ulna and radius. All right, and then your wrist bones, those are carpals. Again, carpal means wrist region anyway. So those are your carpal bones. Okay, carpals. Just know you have 8 in each wrist. You don't need to know the specific names. All right, and then you have 5 metacarpals. Those make up the hand. And then your phalanges are your fingers. Okay, lower extremity, you have what's called the pelvic girdle. There we go. Pelvis is made up of 3 bones. The ilium, that's the largest of the 3. That's the bulk of your hip bone area. Posteriorly, you're going to have this sciatic notch. Anyway, the bulk of your hip, and you can palpate this point. This is the anterior superior iliac spine. That's just the bump in the front of your hip. So if you touch or palpate down in front of your hips, that bump right there is part of your ilium. And then that traces, you can trace it up and back. Yeah, that's the ilium. And then it actually, you can't really trace it here. It kind of disappears. There's a lot of gluteal musculature there. But then you end up on your butt bone. This is called the ischium or ischium. Ischium or ischium. Hey, you'll hear it pronounced both ways. That's your butt bone or your sit bone. And then we come anteriorly into the pubic region where we find the pubis bone. And the 2 pubic bones meet together in the front right here called the pubic symphysis. That's a slightly movable joint. All right. Lastly, we have the lower appendages. We had the humerus up top. Down at the lower appendage, it's going to be the femur. Okay. Femur. And again, here's the head of the femur. This part right here, the head and neck, that's usually what breaks when grandma breaks her hip. This becomes porous and brittle, and it can break. All right. So anyway, femur, and then you have the tibia fibula complex, just like you had ulna and radius up here. We've got tibia, which is medial, just like the ulna, and then you have the fibula, which is lateral, just like the radius. And then you have these 2 bumps on the that make up your ankle bones, medial malleolus, lateral malleolus. Again, those are part of the tib-fib complex. All right, and then we have the patella or the kneecap. And then, of course, we end with tarsals. You've got 7 tarsal bones. The heel is part of the tarsals. That's called the calcaneus. You should know that. And you should also know the talus. That's the distal tibia articulates with the talus. So the end of your tibia, the distal tibia that sits, all your body weight basically comes down onto the talus and the calcaneus. All right. And then lastly, you have your metatarsals and your phalanges. All right. That takes us to 11:20, I want to say, just about anyway. Let me back up. So again, you don't need to know the specific tarsal bones. Know that there are 7 of them. Know the talus and the calcaneus. So I guess you do need to know 2 out of the 7. And again, 5 metatarsals. Those make up the foot. And then your 14 phalanges. All right, so that will conclude our discussion on the skeletal system. It'll also conclude our class. It's already 11:20, if you can believe it. So I'm going to let you guys go. Have a wonderful day, and I'll see you next Tuesday in lab. We're going to be doing a brain and eyeball dissection. So, yeah. Have a good week. Email me if you need anything. Campus is closed Friday, so if you're planning on going to any of our campuses, the school is closed on Friday. All right. Have a good week, everybody.